Welcome back everyone. So in this session we are going to look upon the angle subtended by arc of a circle. We are look upon this particular topic and few important theorems. So let us have a look at the first theorem of angle subtended by arc of a circle. So our theorem somewhat states like that: angle subtended by arc on the center is double of angle subtended on the other part of circle. Now let's just understand what this means, and before proceeding let's just have a look at various scenarios in this the arc and the various angles can occur. So as you can see in our scenario number 1, this is my scenario number 1. In this we have a arc PQ which is a minor arc, and it is subtending this angle right over here, right. This is the angle, right. This is the angle subtended on the center. Now in the second scenario we have the arc PQ, which is nothing but a semicircle, because PQ in this case is the largest chord, which is nothing but a diameter, right. So PQ over here subtends this angle. I hope it is making sense. And in this case PQ is a major arc. It is, firstly we have looked upon the minor arc, then we have looked upon the semicircle, and then I am going to look upon the major arc. So the angle subtended would be somewhat like this. I hope it makes sense to you, right. Now in all of these scenarios this particular theorem fits, right. What it exactly says: angle subtended by an arc on the circle. So whether this arc PQ is a minor arc or semicircle or major arc, angle subtended by the arc will be what? Angle POQ. That is angle POQ. This is the angle subtended by arc on the center, is double of the angle subtended on the other part of the circle. That is the angle subtended right over here. The angle subtended right at this point. The angle subtended right at this point, right. So that is this angle will be twice of angle PAQ. This is what this theorem says, and essentially this is what we have to prove, because without proving we don't just assume anything that it is right or wrong, right. So let's prove that. So in order to prove, what I am going to do, I am just going to analyze the smaller triangle firstly. If I talk about angle BOP, this angle right here would be equals to the angle BOP would be equals to angle OAP plus angle OPA. You must be understanding why I have done this, because this is a triangle. OAP is a triangle and this BOP is the farthest exterior angle, and the farthest exterior angle is equal to the sum of two internal angle. I hope it is clear to you, right? So if this is true, what I have is, now in triangle, if I go with OPA, in triangle OPA, I have OA is equals to OP. Why is that? Because they are nothing but radius. They are nothing but a radius. So if this is the case, then if sides are equal, right, if this particular OP is equal to this side OA, if these two are equal to each other, then what I can say, that the angle opposite to them will also be equal. That is, angle OAP will be equals to angle OPA. And if it is true, my friends, what can I say? This is my equation number 1. What my equation 1 can be written as, angle BOP will be equals to what? OAP is equals to OPA. So if these are equal, then I can write it as angle twice of angle OPA. This can be written as. And similarly, what I can say, that angle BOQ is nothing but twice of angle OAQ and OAQ. See, whatever the derivation I am doing is applicable in all the three scenarios, right? Now, this is my second and this is my third. So from adding, if I add 2 plus 3, so what I'll be getting is angle BOP and BOQ. BOP and BOQ will make angle nothing but POQ, right? POQ and POQ. And if I add the RHS, what I'll be getting is twice of angle OPA plus OAQ will result in angle PAQ only, right? So twice of angle PAQ, right? This is what my 2 plus 3 looks like. Now, what I am going to do from here is, I am going to use this relation in getting, see, that's where I have proved whatever I have presumed in the beginning, whatever was my theorem, I have already proved. Now what I am going to do, I am going to draw an important conclusion from here, and that is, what if this angle is 180 degree? As you can see, this angle right here is what? This is 180 degree. And if this angle is 180 degree, then this angle will be what? 90 degree. So if this angle is 90 degree, so I am going to conclude an important thing from this theorem only, that is, this will be a corollary of this theorem, that is, angle subtended by a diameter, angle subtended by diameter on the semicircle, is always 90 degree, So whether this is right over here, or this could be right over here, or this could be right over at this point, all of those angle will be is always 90 degree and equal and 90 degree, you can say that, right? So that was all about this angle subtended by arc of a circle and this theorem. I hope it makes complete sense to you. Thank you so much.